I'm Will Gardella. This is the Big Data talk track, and I'm the organizer of the talk track, so I'm very excited to welcome you. I'm actually new to Couchbase. I came from HP, where I was part of the Big Data team, and before that I was part of SAP's Big Data team. This session is very personal for me because I think if you watch this session, it kind of goes into some of the reasons why I was excited to join Couchbase. So let me go ahead and just get right into it. What I want to do today in this session is to talk a little bit about NoSQL, Couchbase, and what's new. How many of you are using Couchbase today? So a pretty good number. How many of you have no clue about Couchbase? This is your first exposure to it. Okay, good. So I'm not going to, it's not going to be perfect for everybody. For the advanced guys, it's going to be a little review. For the guys who are new, it's going to be a little fast, but I'll just try and cover everything the best I can. I'm going to get into, after we cover some basic stuff, I want to talk a little bit about analytics and data integration, because this is something that's new in Couchbase that's enabled by Nickel. So I want to spend a little bit of time kind of thinking about what that means. And then I want to talk about big data from the overall perspective and kind of how it all fits together. Hadoop, you got Spark, you got Kafka, you got Storm, you got other stuff. I just wanted to kind of go through that and talk about how they all fit. So this question is a good one. Where does big data come from? I think if you answer this question, it can give you a good idea of how these systems are different and what they're good for and why they are designed the way they are. And I think people rarely think about this question from the perspective that the NoSQL data stores like Couchbase do. Most of the driving forces behind big data right now are the web, cloud, mobile, and Internet of Things type of applications, things that write massive amounts of information. There's been a massive centralization, and this is old history. I'm not going to go into lots of background on this, but these systems have been centralized, and you need systems that are capable of running large applications that scale out. So that means you have to have online systems. You need to have systems that are capable of handling the reads and writes, and they have to be so fast that they're more or less invisible to the user, right? Otherwise, the users wouldn't accept them. So that's the problem that Couchbase was designed to solve. How do you build systems that can scale for internet scale applications? Whoops, I think we should go forward, not backwards. Okay, so I said I would say a little bit about what Couchbase actually is. And when we talk about Couchbase, we're talking about a NoSQL data management solution. And it covers a full range of apps and use cases. If you look at the left side of the screen, starting from the left side of the screen, this is kind of going back in history for Couchbase, but it's built on a high availability cache that was built to be distributed and easy to manage. Okay, so that's the foundational layer. You add on top of that functionality like the key value store, and then on top of that, when you get into things like Nickel, you're talking about a full document database, right, with a lot of extra additional features and capabilities. That's what you heard if you went to the keynotes this morning, right? You're hearing all about these much easier to use, much easier to consume, and much more powerful programming methodologies. And that's what we call Couchbase Server. That's that side on the left. The side on the right is additional data management capabilities for things like Couchbase Lite, which runs on device, and Couchbase, the Couchbase Sync Gateway, which takes care of syncing the remote data sources that you might have in, say, a phone application or an IoT application with a centralized Couchbase server. And so if you add all those up, that pretty much covers what I just showed you with the online applications, mobile, and Internet of Things type scenarios. So if you want to do that kind of data management, then you need to be able to perform consistently with very low latency. That's absolutely critical. And that's one area that's not easy to do. You have to be able to scale, and usually scale means horizontally scale. Basically, you need to add new servers, and they have to be very easy to add to the cluster, very easy to manage. Otherwise, you've kind of defeated the purpose, right? Otherwise, a scale-up type of thing would be like adding more powerful hardware. That's really not the way that most people want to scale this type of an application. Then there's requirements around high availability, and then finally the flexible data model, right? You don't want to be forced to change your application every time somebody else in the organization decides they need a different data model. You don't need to keep in sync with them, right? You can have a very flexible and very agile method of developing your applications. So these things are good properties of big distributed systems, right? And these are things that Couchbase excels at. When you consider Couchbase, and this is tooting my own horn a little bit, or our own horn a little bit, but we just released a benchmark this week that talks about Couchbase. One of the things that we're also very good at, where we are a little bit different from some of the competitors in the NoSQL space, is we're very efficient with hardware. So we released a benchmark with Google. We had 50 nodes of Google Compute Engine, and we were doing 1 million writes a second with about 3 billion records. So it's about a sixth of what we base this on a similar competitor's activity. So it's about a sixth of the hardware that the competitor used. OK, so that's a little bit about what Couchbase is, just in general. This is what's new in Couchbase 4. So the beta came out this morning. And we would definitely encourage you to try it out, see what you like. We're really interested in your feedback. The big things here, the multidimensional scaling, you would have heard about that this morning, right? So I mentioned you've always been able to scale out very easily with Couchbase. Now you can also scale up easily, right? So it's possible to specialize certain nodes for certain workloads if you want to. And you can do things like get a machine with more CPU if you're doing something like indexing on that machine. So it really opens up a lot of possibilities for growing your Couchbase cluster in new ways. And we think this is going to be very exciting. Another thing is NCL, right? The SQL dialect that lets you work with JSON. A very interesting thing. It's very powerful. It combines the best of both worlds. In the SQL world, it's very declarative, very easy to write code. And most people know it, and most tools know it. And that's really what I'm going to be talking about today, is the interoperability with tools and partners that enables for us. And then the Forest DB is going to be a big deal for the big data case as well, because it just unlocks a lot of performance possibilities. It's very efficient. And there are 3 sessions on that. All these things will be talked about quite a bit at Couchbase Connect this year. And I just wanted to include them in my talk because I'm the first guy that you will have heard from today. OK, so let me go into this idea about the NCL opening up the ecosystem. In the past, Couchbase was a key value store. But now that we have NCL, now that we're working together with partners, it's possible to start using enterprise tools that the enterprise would have standardized on together with Couchbase. And so I'm very pleased to have several of these people speaking here with me this week. But we have now, for example, Simba ODBC drivers that allow you to either develop apps directly against the ODBC, JDBC drivers that speak to your Couchbase cluster, or you can use things like ETL tools, Informatica, for example. You can use analytics tools like Tableau and Looker and Microsoft Excel, Metanautics. And this is very exciting, right? So in the past, if you wanted to do this out of Couchbase, you would have had to take the data out and put it somewhere else if you wanted to do any kind of analytics on it. now you can just use the tools that you already use together with the Simba driver. So that's very exciting. And I would encourage you to go to these talks that are in the big data track. Kyle from Simba will be walking through several examples of how to use the drivers. If you haven't seen Looker and Tableau lately, I mean, those and Metanautics, these are all really interesting tools. These will all be covered in the big data track, and they'll talk about how they work together with Couchbase. And so for a lot of people, and Informatica, the ETL tools that they do in the cloud is a way I certainly had never seen ETL done in the old days. Right, this is a very new approach where they use an approach. Partly, the metadata is in the cloud, but all the data that needs to move around and be transformed stays on premise. Right, so this is something that, again, is made possible by Nickel. Okay, so I'm going to move on to another way of connecting Couchbase, the other way that Couchbase fits in with the ecosystem, right? So when we think about big data, usually people are not thinking about systems like Couchbase that are responsible for the online processing of the data. They're usually thinking about Hadoop. And what I wanted to just sort of start off with is this statement that says, it's not really a question of do I need NoSQL or do I need Hadoop. It's sort of like these two things are very different purposes. And I think this is really kind of a source of confusion that people have. When I say where does data come from, and this will become clear in a couple of slides, but when I say where does data come from, it comes out of these operational systems that run the live applications, and then the Hadoop systems tend to be more analytical, right? So you can kind of draw a chart like this and get a bit more concrete about what the differences are between these systems, right? And why you don't need to, give up, Hadoop just because you want to run a NoSQL database, right? They're quite different. So everybody talks about, for example, real time. Everybody wants everything immediately, of course. But when we say real time at Couchbase, we're really talking about trying to get to latencies that are under a millisecond. That is, you can go to talks here this week and hear people how they achieved under a millisecond read-write cycles at massive scale. That's the kind of thing that Couchbase is good at. When you talk about Spark, and people are very excited about Spark, and I am too, you're getting down to latencies in the seconds time over these big analytics, right? It's very impressive. And the Hadoop processing world with new improvements to Hive and other similar projects that do ad hoc querying have really driven the time of the queries down quite significantly. But you're still usually talking about minutes or longer in that area. But of course, it depends, right? Now, if we think about what these things are good at, as I've already mentioned, you've got Couchbase for the online processing. You've got now you have ad hoc query capabilities, which you saw in the keynote, right? You can say, I wonder how many people are flying to San Francisco, and you can just do a query for it now, which is nice. You don't have to build a MapReduce view to get your answer, which was the old way to do it. The ad hoc query performance isn't sub-millisecond. I don't want to give anyone the wrong impression, but when you get into ad hoc queries, it's really hard to compare things, right? That's why we have benchmarks, because if I were you, I wouldn't believe me anyway, right? So that's just the way it goes. So the nickel stuff is very powerful. It's not as fast as going. If you need maximum speed, then there are other ways that people do achieve that. But Couchbase can certainly support it. Spark adds the streaming capabilities. It's generated a lot of excitement. It's really taking a lot of the Hadoop world by storm. It has, of course, the ad hoc and the batch capabilities, but mostly it's used for sort of streaming and ad hoc type scenarios. And then with the Hadoop world, you have, of course, the massive batch jobs that complete. And there's quite a bit of ad hoc capability there as well. So I would just say right-hand side analytical, left-hand side operational. And you can do very advanced analytics on this side, right? When you talk about Hadoop and Spark, you can do machine learning, you can do things that are incredibly complex, and people do. And that's not a good use case for Couchbase. You can also compare who's using the systems. In the case of a Couchbase, you might be supporting millions, or even we have one customer who's supporting somewhere near 1 billion customers. On the Spark and Hadoop side, you don't usually have to support that. You might be building machine learning models that you feed back into the operational store that support a lot of people, but that's not what the users, the end users are not doing that, right? It's the internal staff that's interacting with that system. And everybody says big data, right? Well, we're definitely talking. We're not in the petabyte range, as far as I know. I don't think there are any Couchbase clusters running petabytes of data. But certainly tens of terabytes is a possibility. And again, when you're running at that scale and you need the kind of throughput and latency that you would be able to tolerate with a user who's impatient, like me, who just wants their phone app to load or whatever, right? That's where you need to have the maximum throughput and latency for massive numbers of users. So hopefully that part is kind of clear. So the way these things interact with each other, Couchbase itself publishes a number of connectors that can be used to hook up with external systems. And there are a couple of different kinds of connectors. There are the community connectors, which there are a number of those. And if you go to Couchbase Labs, you can find the GitHub repo for Couchbase Labs. You'll find a lot of these there. But there are community connectors. There are Couchbase-supported connectors. And they allow you to do things like connect out to some of the other ETL-type systems, like Scoop and Talent, or Storm and Spark. There are full text search, like Elastic is going to be here talking. And there's a connector for Solar, for LucidWorks. And there are ingestion connectors. So you have a lot of connectors that you can use to get data back and forth between Couchbase and these other systems. And I'm just about to, in just a second, I will talk about kind of what that looks like. But I want to go through one thing about how those connectors work. So, and if I show you up here at the top, you see that red, that Couchbase to Couchbase replication. So I want to talk about the way that we like to do connectors. And this is using a facility called DCP, or Database Change Protocol. And there, again, you can hear sessions on this as well, but this is something that came in with Couchbase 3.0. So this has been out for a while. And what DCP does is it captures mutations of the data in Couchbase, and then it writes those mutations out. So instead of having to write full sets of all the data, if you have a replica and it knows its state, then all it has to do is catch up with another one. And so we use this in a couple of different ways. We use it for obviously for replicas. We use it for XDCR, which is when you go cross data center, so you have geographic distribution. We can use DCP for that, and we do. And things like maintaining indexes. Now that we have this system where indexes, you might have data distributed, but you have indexes centralized, right? So you can use DCP so the indexes can keep in sync, right? So this is a great way to also capture mutations that we want to write out to these other external systems, the Hadoop, the Spark, and so forth. That way you're not trying to write everything, you're just trying to write what's changed, the deltas. And DCP is very innovative in a couple of ways. So the sync efficiency goes way up because you're not shipping all the data out, especially if you have really large data sets. The I/O gets completely taken out of the picture because it's a memory-to-memory based replication. So you don't have to go to the disk and then read it in. It gets your systems caught up faster because the whole process is faster. So your replicas are more current, and then you don't have as much, you have better durability properties in your system. So right now, we use this internally quite a bit. We have some connectors that use it today. So for example, the Kafka connector, which I'll talk about, and the Spark connector, which I'll briefly touch on, they both leverage this DCP as a way of working those connectors. But right now, the community connectors don't because we haven't published this externally, but that's in the roadmap for us, is that we want to publish the external interface to DCP. Okay, so how many of you guys are familiar with the Lambda architecture already without me saying anything? Okay, a couple of hands go up. Okay, so that's good. So the Lambda architecture, it has a very specific, exact definition, and I'm going to be a little bit loose with that, but basically the Lambda architecture was the people, realized, Nathan Merritt's, was the originator, but realized that you have things that need to go in batch mode and you have things that need to go in speed mode, right? And usually you have kind of different properties of those systems. The batch system is more flexible, it's bigger, it can often have better recovery properties. You get a lot of more intermediate data steps out, whereas the speed layer has to be, by definition, simpler and usually has to be faster. So the idea is you have data that comes in from somewhere at the left-hand side of this system. Often the data can be written both directions at once, so it's a fork in the road. You can write it into the batch system. You can write it into the speed system as well. In the batch system, you have to do something to be able to make that data usable for your analysis, whatever that is. And that's often MapReduce. Down below, you're usually doing stream processing on it because you need immediate results. You want those results back right away. You might be building some sort of incremental views or something that you can use quickly. Then you write it into some sort of a serving layer where you can then use the results of whatever computations you have. Either you're telling people, you have to pay me 50 cents because your ad was clicked on this many times, or whatever it is. But that's going to come out of this serving area. And of course, queries, when you think about, I've got a data set and I want to know how many people did X, Y, Z, that would be another way of using this system. And the complication on this is that often what happens is you tend to build aggregations or partial aggregations. Then you can use those to speed up your performance there for queries. I didn't realize there's a build here. But where Couchbase comes into this picture is mostly on the ends. If you think back to what we were talking about, these operational systems, fast to serve data out of, fast to write data into, updates. So often it's the source of data because it's behind an application. It's running the user profiles or whatever it is, right? Somebody comes in, they update their phone number on the app, and you write that back in, and that's going to go into this whole big tree. But the other thing is that at the other end, when that user goes in and he updates his preference, he says he likes golf or whatever, you're going to go through these models here, and there's going to be some model that's built that's going to show what ad this guy needs to see, for example, just as a random example. So you're building an ad service. Let's say you're doing machine learning. Let's say you're doing machine learning on Hadoop up there on the top in batch mode. At the end, it comes out, and somewhere you need to serve this guy the ad, and the ad has to come really fast. So that may be something that's coming out of a Couchbase, the knowledge of what that guy needs to see. Okay, so let me add a little more richness to this. Put the names on. You probably already know where these guys go. But on the top, you have something like a Hadoop. And this picture is getting a little more complicated in real life. But your Hadoop is basically the system you'd think of as being on the top there with the batch and the maximum scalability. On the bottom, we have systems like Storm, and Spark that are more designed for speed. Yeah. So I just wanted to point you to a couple of things that are coming up, a couple of speakers here. I know I came very quickly through this, and I didn't give full justice to Hadoop or Spark or really anything. But right after this session, Shivaji will be talking from Hortonworks, talking more about the Hadoop story. So if you stick around for a few minutes, you can hear that as well, and he'll go into a lot more details. There are also a couple of sessions on Spark this time. So there's going to be a developer track session with Michael Nitchinger that goes into great detail about how to use it. Databricks will also be here tomorrow to talk about this, and Michael will join for that session as well. But that one will be a little bit more high level, give you the lay of the land a little bit better. And Michael's session will be a little more practical and hands-on. And then there's also stream processing with Spark and Storm. So that's the only one that covers Storm this time, which will be tomorrow evening. Okay. You can't make another session. I just wanted to say, there's one thing that's new is we just released a developer preview 2 of the Spark connector. So this has what the other one had. So this is support for Spark Core. How many people know what Spark is? Okay, so lots of them. Okay, so I didn't want to be reading off a list and you don't even know what I'm talking about. So this lets you create RDDs from documents, views, and NCL queries. So it's a pretty good set of functionality. You can write RDDs and DStreams into Couchbase. So if you think about both ends of the Lambda architecture, you kind of got both ends covered. It's fully transparent cluster and bucket management. This release supports Spark SQL. And you have the Spark streaming supported in experimental form, but that should be coming for GA. And you can try this out now. Okay, so one thing I haven't talked about yet, which I do want to make sure I cover, is Kafka. A lot of the Couchbase customer base uses Kafka with Couchbase. So I wanted to take a minute to make sure that's clear why that is such a common pattern. So Kafka is a data broker. It's a very clever system, actually. It's basically a data broker and has a publish-subscribe system. And what it does, it's like a manifold for your data, right? If you know what a manifold is, right? You take a bunch of inputs and you got a bunch of outputs, and you want to decouple them so that if something goes wrong in one place, it doesn't mess up everything else, right? That's basically the function that Kafka takes. It's a commit log, and it allows you to decouple things. If your messages don't get retrieved in some amount of time, they just go away. So it's very hard to make it fall over. It's a very elegant system. So we have Confluent, which is a new startup that formed out of the LinkedIn guys, Jay Krebs and others, who were the originators of Kafka. They'll be here to talk later today, and then tomorrow PayPal is going to talk about how they use it, and they go into quite a bit of detail about that as well. So it's certainly something worth checking out. And if I were to bring up the Lambda architecture picture again, I could put Kafkas all over the place here, really, because it's a great way to move data around. And so that's kind of it. A couple of other sessions that I haven't mentioned that are mostly in the big data track. There's a session about how LinkedIn uses Couchbase. There's a session that I just pointed to because I happen to randomly be the reviewer for it, but it's a great session about Couchbase performance and how to make your Couchbase cluster really sing. So if you guys didn't believe me, and everyone should always be skeptical, but if you didn't believe me when I was talking about the sub-millisecond response time, it's good to go to talks like that and hear how people tune their cluster, what they do, and the things that are important to go into that kind of performance at scale. So they've got a big load there. And then Moody's is going to be talking later today about how to think about NoSQL from sort of a large data perspective. Avalon is here. They have expertise in running these kinds of systems, so they'll be talking about their expertise. And then there's one last talk which I want to encourage you. It's in the big data track, and I think in one way, it's probably the single best talk you could go to really understand nickel. It's one of my colleagues, Yingyi Bu, who just joined from, he's just finishing his PhD at UC Irvine. And it's a very complete and kind of thorough consideration of why nickel has to be designed the way that it is. What are the semantics of nickel? What semantics need to be covered if you're going to go into data sets that are flexible, but you want to use a SQL approach to doing that. So I would highly encourage you. That's a very rich talk. It's a really good one to go to if you really want to get the meaty full picture. And with that, I will close here. You can get in touch with me. Well, first I'll tell you to try the beta. Then I'll tell you, you can get in touch with me if you have questions. And I think we have time for some questions, right, Rob? Yeah. Yes?
Can you go back to the comparison between Spark, one of the earlier before this?
Yep.
I'll come back to this one. Performance especially.
Oh, I think I skipped it, didn't I?
Milliseconds and so on.
Yeah.
Right? Okay. Here, I want to understand the details about less than 1 millisecond per op. How many customers out of the millions of customers can you handle with that guaranteed latency?
Yeah.
What other parameters are dependent on it's dependent on when the latency is claimed in terms of number of servers, their capability, and network, and how far it is, network latency.
So the question here is what's included in that sub-millisecond response time. And
metric doesn't have any value unless you have the...
Yeah. I actually, in my speaker notes, I actually have the... No, in the speaker notes, I actually put the slide in there, but because Jerry hasn't talked yet, I just took his exact thing. So I would say you can go there. That's the LinkedIn case, and I can show you when that one is. I didn't want to give his numbers away because the way he builds the story, it would be kind of give it away. But yes, but it is good. There are several talks in the operations track that cover that. So yes, I'm dodging your question, but mostly because it's here in the speaker notes, but I just don't want to give.
Back to the Lambda architecture.
Sure.
Okay.
Did we have? Yeah, go ahead.
Here,
which?
You're talking about one side, which is a batch process.
Yeah.
On the other side, in Spark or Tom, it's a streaming process, right? And how do you synchronize, when you merge it, when you start from there, it's not a problem. It assumes whatever it is.
That's correct.
And when you bring it back, how do you, the same data is, ultimately analyzed as well as things for you to be put in an advertisement. And so how do you synchronize to what accuracy, what are the...
Yeah, so let me try to answer your question. So the question is about the two different forks that you have in this architecture, and what do you do with them? Usually the way you would want to think about this is that you do different types of analysis in different forks. What I thought you were going to pick on is something else, but the issue that people have had with this approach, and one of the reasons why Spark is very popular, is that it kind of unifies both branches. Spark allows you to have a single programming model where you can define batch mode type calculations and things that you really want to do in streams. And I think that's really there's a huge benefit of that both in terms of manpower, because you don't have to have some guys who are writing MapReduce jobs and then somebody else needs it streaming, so they have to rewrite it, right? Yeah, so Spark is also parallel. All these are parallel. They're all parallel. But that's a big advantage of that, is that Spark kind of allows you to do both, the same type of programming on both sides. So I think, hopefully that answers the question. Usually different kinds of analysis on different sides. When you bring it together, you're not necessarily trying to make them. When you merge the view, don't think of that as that you have no prior knowledge of what data has gone through which transformations. Usually you know what you've done on both sides, so you're bringing it together for a specific purpose, right? You're not trying to match up like on a single cell of a database or something.
But delay, latency depends on the type of data and all of that.
That's correct. That's correct, yeah. Okay, I'm supposed to wrap up here. Was there any other question I can take? Okay, I can't take a question, he's saying. All right, so I want to welcome up the next speaker, who I can see sitting in the back there. Come on up, Shivaji. I'm going to let him set up.